Okay, let's unpack this. Welcome back to the deep dive.
If you're like most technical teams right now, you've probably mastered the LLM itself. Maybe you've even built some really great chatbots.
Yeah.
But the real architectural frontier, the thing that's coming next, it isn't the chatbot. It's the autonomous software entity we call the AI agent. So today, we are ripping the lid off that architecture. Our sources are, well, they're incredibly dense. We're looking at a full 11-lesson curriculum designed for enterprise teams. And our mission here is to deliver the core blueprint. We need to move past the hype and really understand the operational infrastructure that allows software to, truly perceive, reason, and act on its own.
And what's fascinating here is the sheer scale of the strategic shift these agents represent. This isn't just theory anymore. The adoption is accelerating and fast. Industry forecasts are suggesting just a staggering spike. We're talking 33% of all enterprise software will include agentic AI by 2028.
Yeah, and that's up from less than 1% today.
Yeah.
So if you want a shortcut to understanding the essential, non-negotiable infrastructure behind that massive transformation, this deep dive is it.
Exactly. We are looking at autonomous software that is poised to fundamentally reshape enterprise automation. I mean, everything from back office processing to customer support. So our core objective today is, well, it's pretty simple. We want to understand what fundamentally differentiates an AI agent from the AI you're probably using today, and then identify the 4 essential building blocks you need to create systems that are functional, reliable, and critically trustworthy. All right, so let's start with the basics. For a listener who feels they just got their head around the LLM itself, how does an AI agent differ from a standard model or even a really smart chatbot? What's the architectural jump we're looking at here?
The difference really boils down to intent and persistence. The formal definition is pretty precise. An AI agent is an autonomous software entity designed to perceive, reason, and act in an environment to achieve a goal. Think of it less like a tool you use and more like a digital employee.
A digital employee? I like that.
Yeah, a simple chatbot, on the other hand, it performs a single stateless Q&A turn.
Oh, one and done interaction.
Exactly. You ask it something, it responds, and then architecturally it forgets.
Yeah.
The context needs to be reloaded. It's purely reactive.
So the agent is inherently proactive and stateful. It remembers.
Precisely. The agent takes a foundational model, like a GPT-4 or something similar, and that acts as its brain. But the agent is the whole body wrapped around that brain. It layers on reasoning, dynamic planning, memory, and crucially, tool use.
Okay.
And that's what allows it to manage these complex multi-step workflows. It doesn't just answer, it decides what action to take next to move closer to its goal.
So we've broken down its operation into those 4 key components, right? Perception, which is the input.
Yes, what it sees from the environment.
Action, the output or the tool it calls.
What it does.
The environment it operates in, and of course, memory. And it's the combination of all of those that takes it beyond that single isolated interaction.
That's the key takeaway from the curriculum. The agent isn't defined by the size of its model, but by the architecture that lets it hold state and execute real plans.
This is where it starts to feel like a living system. These agents, they live and breathe by a continuous cycle we call the observe, think, act loop. Walk us through the dominant design pattern that drives that whole process, because it's a huge departure from traditional code.
The foundational pattern, the one we see powering all the really effective tool-using agents, is called REACT. That stands for Reason plus Act.
REACT.
And it's what differentiates a flexible agent from just a rigid script. See, instead of just creating an output, the LLM interleaves its chain-of-thought reasoning with actions.
What does that look like in practice?
Well, the agent explicitly outputs a rationale first. For example, it doesn't just suddenly search for a customer ID. It first outputs something like, thought. I need to find the customer's latest order status, so first I need their ID. Action. Call database lookup with the customer's name.
So it shows its work.
It shows its work. Then it observes the result from that action, and it iterates.
I like the analogy we used earlier. This is so different from the older plan and execute pattern.
Oh, completely.
That pattern is like a fixed train schedule. You plan every single stop before you leave the station, and if one track is blocked, the whole plan just fails.
Right. Whereas React is more like a live GPS navigator. It's constantly course correcting based on real-time feedback. If that first tool call fails, the agent reasons about why it failed. It updates its plan, and it tries a new revised action. That iterative approach is absolutely critical for the real world.
But those actions, they rely entirely on tools. Why can't the LLM just do everything itself? What are the big limitations?
That's a fundamental piece of the architecture. The LLM brain alone is brilliant at reasoning, but it has three massive shortcomings that make it pretty useless for enterprise automation on its own.
Okay, what are they?
One, it lacks up-to-date, real-time, or proprietary information. Its knowledge is capped at its training date.
Right, stale information.
Two, it cannot perform reliable calculations. LLMs hallucinate math constantly. You just can't trust them with numbers.
And three.
And three, it can't actually do anything in the real world. It can't execute code. It can't send an email. It can't query a live database.
It's just a brain in a jar.
Exactly. Tools fill these gaps. They augment its capabilities, turning the agent from a passive tech system into an active participant. Tools are its arms and legs.
So what are the common categories of tools that every organization needs to be thinking about?
We usually group them into three layers. First, you have knowledge tools. Things like web search APIs or queries to a vector database. They solve that stale information problem.
Makes sense.
Second, calculation tools. A Python interpreter, a calculator API, something that offloads the math to a system that's actually reliable.
And the third one is the big one for business, I imagine.
It's the most critical for enterprises, yeah.
Great.
Integration with enterprise systems.
Yes.
These are your CRM, ERP, and database APIs that let the agent read and write company data. That's what makes it useful.
And the curriculum really emphasizes that the most reliable way to integrate these is through a structured function or API calling approach. Why is defining that schema so much safer than just letting the LLM generate free-form code?
It boils down to governance and safety. When the LLM outputs a structured function call, it's constrained to specific functions that you provide, with very specific arguments.
So it's not making things up.
Right. It's not generating arbitrary Python code.
Mhm.
This gives you a transparent, auditable layer. You know exactly what the agent intended to do, which is so much better than relying on its text description of an action. It builds a safe, controlled boundary.
That structured approach mitigates a lot of risk. But even the best tools don't matter if the agent forgets what it was doing 5 minutes ago.
Oh,
Which brings us to the agent's Achilles heel, context limits.
absolutely.
Yeah.
The LLM's short-term memory is, it's just constrained by its token capacity. Maybe 4,000, maybe 16,000 tokens. That's enough for a few turns in a conversation, but not for managing a 3-day, multi-step business process. If you go past that window, the agent gets, short-term memory loss.
So how do they get around that bottleneck to maintain consistency?
They use a more sophisticated memory architecture that moves knowledge out of that immediate context window and into persistent storage. We really differentiate three critical types of memory. First, you have that limited short-term memory inside the context window.
The immediate conversation.
Right. Second, you have long-term memory. This is persisted knowledge stored externally. Factual data, company policies, user preferences. This is how an agent remembers a customer's issue from 6 months ago.
And then there's the third type, which is where it starts to feel like it's actually learning. Episodic memory.
Yes. Episodic memory is the agent's log of its own experiences. It's a record of every action it took, every tool it called, every outcome, and every mistake. By reviewing that log, the agent can understand why a certain strategy failed, and it can adjust its future plans. It's how it gets better over time.
Now, when we talk about implementing that crucial long-term memory, that factual knowledge, the term that just dominates the conversation is Retrieval-Augmented Generation, or RAG. For anyone just catching up, can you break down how RAG actually works?
Sure. RE is the key mechanism for integrating all your proprietary knowledge, internal documents, policies, you name it. The process is straightforward but really powerful. You take your source text, you convert it into numerical representations vectors using an embedding model, and you store those vectors in a vector store.
I always think of the vector store as a kind of high-tech library catalog that stores concepts, not just keywords. It understands meaning.
That's a perfect analogy. So when a query comes in, the agent converts that query into a vector, searches the store for the most similar, relevant text chunks. And here's the crucial part. It injects those snippets directly into the LLM's prompt, along with the original question.
So RAG isn't just about reading more data, it's about provenance. It means every answer comes with footnotes attached.
Exactly. This grounding in evidence dramatically reduces hallucination because the LLM is forced to respond based on the retrieved material, not just its general training data. And the data on this is compelling. Agents using long-term memory with RAG showed a 35 to 45% improvement in success rates on complex tasks. That is a non-negotiable level of reliability.
Which brings us to the most crucial piece for any enterprise: safety. As we grant these systems more autonomy, more access to data through tools, the risk profile changes completely. I mean, uncontrolled autonomous behavior is a serious operational risk. What are the major hazards we have to mitigate?
The hazards, they just jump significantly once you add tools and autonomy. The three big ones that keep security teams up at night are, first, tool misuse.
So the agent doing something destructive.
Right. Performing unintended actions, like deleting critical data, just because it was granted write access when it only needed to read something. Second is prompt injection. This is an external attack, someone trying to trick the agent into revealing secrets or acting outside its scope.
And the third is the classic one.
The classic one, yeah. Hallucination, still a problem. Outputting fabricated information, which in a business setting could trigger a compliance issue or just lead to a terrible decision.
So how do we wrap a robust safety harness, the guardrails, around the entire operation to mitigate these failure modes?
We apply guardrails at every step. For tools, you need absolute tool permissioning. This is the principle of least privilege. The agent only gets the minimal tools it needs, with minimal access.
Read-only access to a database, whitelisting specific APIs.
Exactly. It's basically embedding zero-trust principles into the agent's design.
And before the agent even starts thinking, you have to screen the input, right?
Correct. Input validation and content filtering. You use specialized moderation models to screen all user inputs for things like prompt injection attempts or toxic language before the agent ever sees it. If it's malicious, the process just stops right there.
And for high-impact decisions, you really can't skip the human in the loop, or HITL.
That is the ultimate backstop. HITL requires a human to approve sensitive or irreversible actions. So think about an agent that identifies a security issue and wants to execute an API call to isolate a server. You want a human to sign off on that before it proceeds.
Absolutely. I also remember reading in the curriculum about step limits. It sounds so basic, but I can see how an uncontrolled agent could just run away from you.
It happens all the time with early systems like AutoGPT. Agents get stuck in these recursive loops, trying to achieve an impossible goal, making endless, expensive tool calls. We've seen agents blow through a $5,000 token budget in a couple hours because they got stuck. So step limits just impose a cap on iterations or tool calls. It's simple protection against runaway costs and chaos.
Okay, let's shift to the cutting edge. Once you have the LLM, React, RAG, and the guardrails all locked down, where do you go for truly advanced reasoning?
That moves us into what's called metacognition. It's the agent's ability to reflect on its own outputs or reasoning. It's literally thinking about its own thinking. This is often implemented with something called a critic-actor model.
Okay, break that down for us. What is a critic-actor model?
In simple terms, the actor agent produces a plan or an answer. Then, a separate process, the critic, critiques that output.
It reviews its own work.
Yes, it looks for quality issues, safety violations, logical inconsistencies. This reflective feedback loop allows the agent to self-correct and revise its approach before taking action. It's how a system really learns to optimize its future plans.
That sounds incredible for complex sequential tasks. But as things get even bigger, we start to see multi-agent systems.
Correct. This is about breaking up the massive cognitive load. Instead of one monolithic brain trying to do everything, you deploy specialized agents. You might have a planner agent for strategy, an executor agent that just handles tool calls, and a critic or verifier agent that focuses only on compliance and safety.
Like a specialized business team.
Exactly. It gives you parallelism, cognitive diversity, and redundancy. If the planner fails, the whole system doesn't crash. It mimics a high-performing team to get greater reliability and throughput.
Finally, as these systems move from a pilot to production, which is what the later lessons focus on, what are the key operational issues for, say, IT and finance teams?
Oh, they're paramount.
Yes.
First, you have to have robust observability. Because agents are autonomous, you need to log everything, every action, every decision, every tool use. This ensures traceability, which is crucial for compliance and auditing. If an agent deletes a file, you need to know why it made that decision.
And I imagine cost management is something people overlook until the first bill arrives.
It is vital. Agent actions are expensive. They involve multiple LLM calls. So cost management requires sophisticated model tiering. You use smaller, cheaper models for simple tasks like initial triage or basic formatting. You only bring out the powerful, expensive models like GPT-4 for the really complex reasoning or reflection steps. That alone can save you massive operational costs.
So to recap the blueprint for building these resilient enterprise-grade systems, it's a powerful LLM brain,
The core intelligence,
a structured reasoning pattern like React,
the decision-making framework,
long-term memory via RAG,
to ground it in reality,
and a robust safety harness of guardrails, including that human-in-the-loop control.
and understanding that full architecture is the difference between an interesting proof of concept and a secure, scalable product. These agents really are the next evolution, freeing humans from so much routine work, but only if they're built responsibly.
So now that we understand the complexity of agent planning and its ability to not just execute, but to actually reflect on its own mistakes and replan its strategy, consider this. If the system is capable of true self-optimization, how much autonomy versus human control should an enterprise truly afford it? That balance between letting the agent learn and innovate and ensuring it never violates budget or policy, that is the central, enduring design challenge for the next wave of AI products you're going to build and encounter. Thanks for joining the deep dive.